Hello students, in this video we will be solving a couple of problems from exercise 7.2 based on the midpoint theorem. We'll see what is the midpoint theorem. First we'll have a look at question. If 1, 2, 4, y, x, 6 and 3, 5 are the vertices of a parallelogram taken in order, then find x and y. Now we know a parallelogram has opposite sides as parallel and equal, but in addition to that we also know about one more property of parallelogram, that is its diagonals bisect each other. Okay, so they bisect each other, meaning that divide each other into equal parts. So if we take this as A, B, C and D, okay, that means BD is equal to AC and it divides each other at this particular point into equal parts. Now what do we need to find out? We need to find out x and y. We don't need to find out this particular point, but we just need to find out x and y. At this juncture we use the midpoint theorem. Okay, now the midpoint theorem says what? Let's say if this is a point and we say call this a point P. Okay, so as per the midpoint theorem we need to find out the coordinate of P, okay, where P divides let's say line segment AC into equal parts or into equal ratios, which means M1 will become equal to M2. In that case our formula, section formula, which is M2 x1 plus M1 x2 upon M1 plus M2 and M2 y1 plus M1 y2 whole thing upon M1 plus M2 will change slightly. Since M1 is equal to M2, if we take this as equal to 1, this will also be 1. So we change this to 1 plus 1 becomes 2. So M1, so this will become just x1 and this will become x2, because it will be 1 into x1, 1 into x2, and this will become 1 plus 1, or in other words 2. Similarly this will be y plus y2 whole thing upon 2. Got it? Why we have taken it 1 both places? Because they are equal. When they are equal they automatically will become 1. Even if let's say it is divided in the value of M1 is let's say 6, then the M2 also has got to be 6, right? So 6 and 6 cancel and we will get 1:1. That is why it doesn't matter, and that is why we take this as 1 and substitute in place of M2 and M1 we substitute equal to 1, and 1 into x1 gives us x1, 1 into x2 gives us x2, 1 plus 1 gives us 2. Similarly over here 1 into y1 gives us y1, 1 into y2 gives us y2, 1 plus 1 gives us 2, and this is our midpoint formula. Applicable. Why midpoint formula? I'll write this as midpoint formula. Why is this midpoint formula? Because this is applicable only where the point which we are discussing about divides the line segment into equal parts, and only a midpoint. Midpoints means middle point, a point in the middle, and middle meaning such that the line segment on either part is equal or divided into equal sections. That is why it is called as a midpoint formula. Only then we use this particular formula. In case of a parallelogram, the diagonals bisect each other into equal parts, which means this particular point becomes the midpoint, and we can apply the midpoint formula. We don't have to mention it, we just can directly use this formula. So let us first assume and we have just been given the coordinates, so let us give them some name. And A will be our 1, 2, B will be 4, 5 because 4, y, and you see it's mentioned over here, take in order. X, 6 will be our C coordinate, and D will be 3, 5. Now our job is to write down the coordinates. So we put first we assume let A 1, 2, B 4, y, C x, 6, and D 3, 5 be the vertices of parallelogram ABCD, and diagonals, you can say, of a parallelogram bisect each other. So you can say at P, I will put it say, because we are just assuming that point. So if we take P corresponding to point, so that would be x1 plus this will be not x1, x2, because if we take this as x1, y1, this will be x2, y2, this will be x3, y3, and this will be x4, y4. So it won't be x1 plus x2 in this case, because that doesn't form a line segment. We are talking about the diagonals. So it will be, if we take x1, it will be x1 plus x3 upon 2, y1 plus y3 upon 2. Now we write this down. What is x1? x1 is 1 plus x3 is x upon 2, and y1 is 2 plus y3 is 6 upon 2. Let's say P corresponds to 1 plus x upon 2, 8 upon 2, 2 and 8 cancels, we get 4. You say P corresponds to 1 plus x upon 2, 4. Now this is of course using x1 plus x3, but we can also use x2 and x4. So, and that too corresponds with P, because they are diagonals bisecting at the same point. P corresponds with x2 plus x4 upon 2, y2 plus y4 upon 2. Okay, see, try and understand why I am taking both P. See, this P I am taking for line segment. I'll put it over here. Line segment x1 and x3 I am taking for AC. Okay, and this P is for, I'll put it over here, BD, line segment BD. Okay, I am applying midpoint formula for line segment AC in this case, and this is what I am getting. Here I am applying midpoint formula for line segment BD. Now both of them, the midpoints are P. They both intersect at the same point. They bisect each other, remember. So that is why we can take it equal corresponding to P in both cases. X2 is 4 plus x4 is 3 upon 2, y2 is y plus y4 is 5 upon 2. We take P corresponds to 4 plus 3 is 7, 7 upon 2, y plus 5 upon 2. Okay. Now since this I'll put this as 1, this as 2. From 1 and 2 we can say from 1 and 2 we get x coordinate will correspond with x coordinate, right? So 1 plus x upon 2 equal to 7 upon 2, and we will also get 4 equal to y plus 5 upon 2. This 2 will cancel and we'll get 1 plus x. I'll do it over here. We'll get 1 plus x equal to 7. Okay, that would be x. If I take 1 on the other side, it will be 7 minus 1, x equal to 6. And in case of this particular, put it over here. So this would be, I'll take 2 and multiply it with 4. So I get y plus 5 equal to 8. I take 5 on the other side, it will be y equal to 8 minus 5, y equal to 3. So I get the value of x as well as the value of y, which is actually what we are asked. X is 6, y is 3. Coming to the 7th problem, it says find the coordinates of a point A where AB is the diameter of a circle whose center is 2, minus 3 and B is 1, 4. So we will draw a small rough circle and the center here and a diameter. So diameter passes through the center of a circle. It's actually two radii, okay, joining each other at the center and meeting the circumference. So this is a diameter, okay, and in this case the center acts as a midpoint of this line segment, let's say AB. We are asked to find the coordinates of A, so we'll have to assume this as say x comma y. B we are given as 1, 4, and we are given the coordinates of the center, which is we'll take this as O, and this is 2, minus 3. We can apply the midpoint formula over here because O acts as a midpoint of AB because O is the center of the circle, and we know that O is the midpoint of the diameter AB. So let's assume, first of all we'll assume A, let A x comma y be, or we'll say just let A correspond to x comma y and O be the center of the circle. That is the first thing that we assume. We have been given B, we don't have to assume this. We have been given the therefore we can say therefore O corresponds to 2, minus 3. Now we say since O is the midpoint of AB, therefore we can say O corresponds to, you can apply the formula which is x1 plus x2 upon 2, y1 plus y2 upon 2. This will become our x2 and y2, and this will become our x1 and y1, which we assumed as x and y. And we have been given coordinate of O as well. So we put O over here, 2, minus 3, corresponding to x1 is just x, x2 is 1 upon 2, y1 is y, and y2 is 4 upon 2. Now to find out x and y is easy. We need to find the coordinates of A. To find that, this x plus 1 upon 2 corresponds with 2, and minus 3 corresponds with y plus 4. So in this way we will be able to find x and y. We'll take x plus 1 upon 2 equal to 2. 2 goes and multiplies with this, so we'll get x plus 1 equal to 4. We'll take 1 on the other side to become negative, we'll get x equal to 3. Similarly, we take y plus 4 upon 2 equal to minus 3. 2 multiplies with minus 3, we get minus 6. I'll take 4 on the other side, it will become negative, and we'll get y equal to negative 10. So you can say therefore A corresponds to 3 comma minus 10, and we are just asked to find the coordinates of A. Those are the coordinates of A, that is 3 comma minus 10. With this we complete solving 2 problems in this video. If you like watching this video, click the like button. Please share it with your friends and classmates. Subscribe to the channel and do not forget to click on the bell icon to receive updates. Thanks for watching. See you in the next video.